Good afternoon, students. Welcome to the course of Advanced Green Manufacturing Systems. We were just going through how the equations can be used, and we are now going to see how these things are getting done in practical. But remember that we are interested in going to use these two equations for calculating the total values and fill this table. Okay. So, this was the data that we looked into the system. This is your factor, as we mentioned earlier. Okay. These are our levels, A levels. These are our replications, okay, N, right. So, in this case we have what is called as A is equal to 5, little n is equal to 5, right. So, you can calculate big N as A times little n, which is 5 times 5, 25. So, the big N here is 25 in this regard. Okay. I told earlier is we are supposed to calculate something called yi dot. Okay. Yi dot is the so yi dot is calculated as I dot is equal to sigma I j is equal to 1 to n yi j. So, for each value of I, for each value of 1. So, in this case this is given by 7 plus 7 plus 15 plus 11 plus 9. Okay. That will give you a value of 49, right. Then this case the second value you can do is 12 plus 17 plus 12 plus 18 plus 18, right. So, that will give you, that is 12 plus this is 40, 77, right. So, you get the value of 77 in this regard. Then this yi dot is 14 plus 18 plus 18 plus 19 plus 19, okay. That should give you 88, okay. And then you have the fourth one as 19 plus 25 plus 22 plus 19 plus 23 should give you 108. Okay. The last one is 7 plus 10 plus 11 plus 15 plus 11 should give you 54, right. So, these are the individual sums. As I said earlier, again these are the sum of the rows. Okay. So, remember this is the sum of row values. Okay. Each individual row values are summed. Okay. Then I can do something called as y dot dot. Okay. Y dot dot, and the y dot dot is equal to y1 dot plus y2 dot plus all the way to y5 dot in this case. So, I sum these up, which is 49 plus 77 plus 88 plus 108 plus 54, that should give me 376. Okay. So, this is the total sum. So, okay. This is equivalent to summing all these values. Okay. Sum should give you this one, right. Now, what the next one we are going to do here is yi bar. Okay. I wrote it as bar. So, yi dot bar. Okay. So, that is the average of these. So, this is calculated as 49 divided by 5. So, there is 1, 2, 3, 4, 5 observations, right. So, the yi dot bar is equal to yi dot divided by n. Okay. So, that is the way you do, you divide it by the n is 5 here, right. This will give you the value of 9.8. Okay. This is 77 by 5, okay, which is 15.4 in this regard, right. The third number is what we calculate as 17.6, which is 88 divided by 5. Then 108 divided by 5 is 21.6 and 54 divided by 5 is 10.8. Okay. So, these are your averages, right. And then I can do something called as y dot dot bar. Okay. So, I can find the entire averages of it, which is y dot dot bar is equal to y dot dot divided by n. I can do that. So, this is, in this case it is 376 divided by 25. Okay. I can get the value, it comes close to 15.04, right. So, this is an estimate of mu, okay, an average, it's kind of an estimate of an average. Okay. So, going through once again quickly, first we do the totals. These totals are the raw totals, okay, and what you do is you sum each individual values of the row, sum them together, that will give you the raw totals. You do the 5 raw totals, then you do the average, this is the raw averages, okay, and what you do is you take the sum total divided by the number of observations in the how many replications are there, you get this value. This is your total, grand total, okay. This is given by summing up of all the values. So, I told you how do we calculate y dot dot, you can do this one or you can calculate all the values, you get it to us 376, and this is y dot bar, then you calculate this. How do we do that? Here is the equation that I told you, okay. So, this is the first step of analysis, okay, analysis step 1, right. Then the thing is, we use ANOVA, analysis of variance, to test H0, okay, H0 as mu1 equal to mu2 equal to mu3 equal to mu4 equal to mu5, okay. We are initially testing the that. So, this is your what you call as null hypothesis, okay. You believing that all the means, the treatment levels have no belief on the no impact on the soldering defects, okay. And the alternative hypothesis, okay, is H1. What are we going to do? The alternate hypothesis, some means are different. So, we are saying that not all of them are the same, some of them have a different impact on that. So, if you reject the null hypothesis, okay, so if rejected null hypothesis will allow us to believe this, okay. So, it is like the same way as please take a textbook, basic probability statistics book to study hypothesis testing, okay. But in this case, anyway, I am assuming that you guys have already gone through it, but always the null hypothesis, the belief is that the treatment levels have no impact on the means, and if that belief is not right, then we believe that some of the means are different. That is the alternate that we are going to take, and we have already seen how these numbers are actually calculated, right. Now, second step of the analysis is, okay, analysis step 2. We do the computations, but remember, most of this kind of time you have large number of data in when you are doing in a factory, you have many number of machines and lot of experiments and lot of data that you have collected. So, doing this manually is not really an easy thing, but this is a small example problem. So, I can do these kind of things manually to show you how the problem computation works, but in real life you would use a software program like sometimes SPSS or Jumpin or something like that, or things like Excel to do this. But here we are actually doing this by hand just to show you the mechanics of the system, all right. So, first thing we need to do is we need to calculate the sum of squares, okay, SS total. So, let us first calculate sum of squares of total. Remember in the previous equation that I told you, we calculate the SS total here, and here is an example of the SS total. Then you calculate SS treatment, from there you calculate everything else, right. So, going back to this, let us calculate the SS total, okay. The SS total is given by the equation sigma I is equal to 1 to A sigma j is equal to 1 to n, little n. Okay. So, in this case the a is, this is 5, this is also 5. Okay. A and n are 5 5 each. Okay. Y I j square, okay, minus y dot dot square divided by n. This is the equation that we actually, we do not need a parenthesis, I am sorry. Okay. So, this you square the sums and then you, from this you subtract it, which if you elaborate it, it is written as, if you go back, these are the values. So, 7 square plus 7 square plus 15 square plus 11 square plus 9 square plus 12 square plus all the way up to this last 11 square. Okay. So, we do that here, 7 square plus 7 square plus 15 square plus all the way to 15 square plus 11 square. Okay. So, the first term, this part of the term is this, okay, it is this one, this is the first term, okay, TRM term. Okay. How did we calculate? This is 7 plus 7 plus 15 plus all these values, we square them, square them, square them, square them, and this is the last 15 and 11, and then you sum them up, right, minus, okay, this is the first part of the puzzle, this is the first part, first term, minus y dot dot, y dot dot you calculate it as 376, okay, is right here 376. Okay. So, we say it as 376 square divided by n. N was calculated again previously here as little n was calculated as 25, not little n, big N was calculated as 25. So, you divide by 25. Okay. So, again the first term is you square each individual values, each individual values are squared and summed together, right, and that gives you the first term, and then the second part, okay, is the this total sums squared divided by 25, and when you do this number, I have calculated this already. So, I will give you the number 636.96, right, this is the value you will get, right. So, please remember this, how this calculation was done, right. Then the next one we do is sum of squares SS treatment. Okay. Sum of squares of treatment is calculated by the equation. So, we already told you what the equation is. The previous case 1 over n divided by multiplied by this equation, right. So, we are going to do that using here 1 over n multiplied by sigma I equal to 1 to a, okay, I is equal to 1 to a, y I dot square minus y dot dot square over n, right. So, this is the equation that we did here, which we are exactly going to do here. The value of a is 5. So, we will be doing this 5 times. Okay. So, which is equal to 1 over 5, little n is 5, okay, 1 over 5 multiplied by, okay, the y I dot square is, the y I dots are exactly here. So, it is 49 square plus 77 square plus 88 square plus 108 square plus 54 square, right. So, what we are going to do here is, it is 49 square plus the next one is 77 square plus all the way to 54 square. Okay. This is the first term, okay, where you are having each one of these sums, you square them, okay, and that, and square them and sum them up. So, this is what you have as your first term, right. Okay. Then minus your y dot dot, y dot dot as I said earlier is 376 right here, sum total of is, that is 376 whole square divided by big N is 25. Okay. So, you have the both the terms, and I get this as 475.76, right. So, this is the second number I have already calculated. So, we have calculated the sum of squares of total and sum of squares of treatments, we have done both, right. Then how do you calculate sum squares of errors? Okay, is calculated by SS total minus SS treatments. So, where did I get this? I got this in the matrix. Remember this, the error sum of squares were calculated as sum of squares of total divided minus sum of squares of treatment. So, using that what I am going to do it is equal to 636.96, this is what I calculated right there, minus 475.76, this is the sum of squares of treatments. Okay. Both of them put together I get it as 161.20. Okay. So, I calculated my sum of squares of total, sum of squares of treatment, and I calculated the sum of squares of error. So, what I have done is I have calculated all the sum of squares from the so that I can start filling the table in this regard, right. Okay. So, these calculations, as I told you earlier, please remember that these calculations are always done with the help of the computer software. Now, we get into the last step of analysis, the third step of analysis. What the first thing we need to do is we prepare the ANOVA table. Okay. So, you prepare the ANOVA table. Where did we see the ANOVA table? This was your ANOVA table, right. This is what we call as our ANOVA table. So, let us go back and try to prepare the ANOVA table. So, I will just draw this. Okay. So, first thing is we have source of variation, okay, and we have as the source of variation, it was, remember this was between treatments. So, the main source of variation for us is the conveyor speed. This is your treatment, that is your source variation. Then the next one is you had is error, and so if you think about it, it is treatments, error and total, right. So, we go with the same fashion, total, right. This is our setup, and the second one is sum of squares. Okay. So, where did we get the sum of squares? We have already calculated it, 636.96, 475.76, 161.20. So, we go back and we fill those values. Okay. So, the first one is the total is 636.96. So, 636.96. I always write it in this fashion so that I do not make any mistake. Then the treatment is 475.76. So, it is 475.76. This is your treatment, by the way. Okay. Please remember that. Okay. And then the error is calculated as the difference of them, 161.20. So, it is 161.20, right. We write the sum of squares in this regard. Then we calculate what we call as the degrees of freedom. Okay. Okay. So, the degrees of freedom, as I said earlier in the ANOVA table, okay, degrees of freedom is a minus 1, n minus a, n minus 1, right. So, let us do a minus 1. So, the value of the degrees of freedom here is, it is a minus 1 is 5 minus 1 equals 4. So, this value will be 4. Okay. This is n minus 1, right. So, if you remember this is written as n minus 1 as the degrees of freedom. So, n minus 1 is equal to 25 minus 1 is 24, right, 24, right. And this degrees of freedom, error degrees of freedom was written as n minus a, right. So, if you think about it as n minus a, that is 25 minus 5 equals 20, okay. This value is 20. One other way to check whether you got the degrees of freedom correctly is, okay, if you look at these, okay, these two difference should be this difference. Okay, remember that. That is another way to think about it. You calculate this. If you take the difference of the total and the treatment degrees of freedom, then the error should also come to that, and you can independently calculate by this particular equation as well, right. Then the next one we calculate is what we call as the mean squares. Okay. So, the mean square is calculated in this case is mean square treatment, okay, is given by sum of squares of treatment divided by degrees of freedom. which is equal to 475.76 divided by 4. Okay. And when you do that, you actually get a value of 118.94. Okay. So, the value goes here 118.94, right. Then the next mean square is the mean square of error, okay, is given by sum of squares of error divided by degrees of freedom, which is 161.20 divided by 20, which should give you 8.06. Okay, 8.06. This value goes right here, right. So, this is your mean squares. I told you again, the mean square is the sum of squares divided by the degrees of freedom. Sum of squares divided by the degrees of freedom. Then what we do is we calculate the f value. Okay. F value is calculated as I told earlier also, is that the f ratio is the mean squares of treatment divided by the mean squares of error, right. So, if we use that, the f0 is equal to ms treatment divided by ms error, which is 118.94 divided by 8.06, you get the value of 14.76. So, this value f0 14.76 goes right here, right. Now, that being said, now we have calculated all the major values. If you think about this table, we have filled almost every values right here. Now, the thing is we have to make a decision out of this, right. So, the calculated value. So, the f value is used to make decisions, okay. Use the f table in textbook, and for 95% confidence or alpha equal to 0.05, whatever it is, you look at the f value. So, you are looking at f of the f is given by usually calculated as you have the f of a and error degrees of freedom. Okay. So, that is f of 4 and 20. Okay. So, these two error degrees of freedom goes here. For 95% confidence interval is 2.87, right. This is the value if you look into the table. I would recommend you to look into it. Okay. So, this degrees of freedom goes by the degrees of freedom of treatment and the error. Okay. So, this is the treatment, this is the error. Okay. You calculate both and then you get the value as 2.87. Okay. So, what happens here is, if you think about it, it is like a probability distribution, something like this, and you are saying the critical value somewhere is 2.87. So, anything above this is rejection, reject H0, you are rejecting the null hypothesis. So, since 14.76 is larger, okay, much larger than 2.87, okay, we reject H0, we reject the null hypothesis and conclude that treatment means differ, okay. So, you are saying that yes, as of now, because this value is so large, we are saying that the means are different in a sense that these conveyor speeds, whatever the speed you select, okay, these speeds have a important significance. So, the conclusion is that the speed of conveyor is important. Okay. So, you have you have now identified a one way to figure out a factor that is significant, means this is a significant factor. Okay. So, for this soldering machine, the conveyor speed is an important factor. That is the conclusion that you are able to now take out of this. Same way you do this for multiple factors, and some of the factors will come out to be significant, some of them will come out not to be significant. So, whichever comes out to be significant, those are the factors that you need to take it outside for optimization. So, I hope now you understand how we selected the factors that are to be taken into an optimization model, right. So, we select all this set of initial set of parameters, and then from there we do what we call as a analysis, especially collect data, do experiments, and then we test the hypothesis that different treatment levels of this factor has importance or not importance, and when you can do an ANOVA, it will tell you yes, this factor is significant for you. The answer is yes, then you take it forward. Okay. So, with this what we do is we have come to a conclusion of this analysis of variance, single factor analysis of variance. Please work out the example and also do the homework problem, because it is important that if you do not do this, practice it, then you will forget this and you will not be able to do a proper job of understanding this. So, please do the practice problems, please do the homework, please understand this is an important technique for you to learn, and please do the needful. In the next class, what we will try to do is we will try to do the factorial experiments, so that just you have an idea of which level is more important. Okay, we are now say that this factor is important. Now, the next step will also tell you which of the levels are more important for you, and that once we finish that, then we will go back and look into the optimization algorithms and stuff like that. Thank you very much for your patient hearing, and I wish you all the best. Thank you.